All right, so this next set of notes is about systems of equations and substitution. This actually will cover like 3 separate worksheets because substitution gets progressively more difficult, and so I made it into different worksheets. The basis, the theory for it is the same though. So hopefully you know what the word substitute means, and that's to replace. Things of equal value. So you're trying to switch out things that are the same. So this happens in basketball, right? You can do basketball subs, in and out, right? You sub in, you sub out. I think of it as $1 can be switched in and out with 4 quarters because they're the same thing, right? And same thing happens in cooking. You could substitute ingredients. Like butter and margarine. So substitute literally just means to replace things. So in math, what's going to happen is you're going to have 2 equations like we had on that other one before. The simplest kind, well, let's even before I get into equations, I could give you x equals 7, y equals 4, z equals -3. And I could ask you something like, what is x minus y plus z? And all you're going to do is you're literally just replacing the things that are equal to each other. So this becomes 7 minus 4 plus -3, which equals to 0. I could ask you, what is 3x plus 2y minus 6z? And this is where you just got to be a little more careful. When they're next to each other, it means multiply. Right. So what's happening here, it's not going to be 37 plus 24 minus 6 -3, whatever that would be. It's 3 times 7 plus 2 times 4 minus 6 times -3. 21 plus 8 plus 18, 29, 39, 47, I believe. Okay. That's one set of substituting, right? You're plugging in one thing for another. I think there's another question on your assignment where I ask you something like, find j. And then I'll say something like x equals 9. And then I'll say 3x plus 4 equals j. All you're doing is you're plugging that in. 3 times 9 plus 4 equals j. 31 equals j. So that's like the easiest type of substitution. So what we're going to do now is get into slightly more complicated. It's still not too bad. I can give you an equation like y equals 2x. And this is getting into what we're going to really be doing. 3x plus 2y equals... Nah. Seven. So what I like to do is I call it, I don't know, boxing things in a little bit. You're looking for single variable equal to something. So substitution, by far, you can do it when there's not a single variable, but you have to do some work ahead of time. So, like I said, I like to box. So y equals 2x. So I'm like, well, y is the same as 2x. So $1 is the same as 4 quarters. So right here, if I don't want $1, I'm going to replace it with 2 quarters. Right? 2 times 2x is 4x. You get 3x plus 4x equals 7. 7x equals 7. X equals 1. And then you might think that we're done. Basically, you've solved it, but if you notice, there's x's and y's here, so you've always got to know both. So what you always end up doing is plugging it back in here. Y equals 2, but instead of x, it's 1. So y equals 2. You should always plug back in. Because you need both variables. And that's really all substitution is. It just gets a little bit more complicated in how the equations are set up. So that's the easiest version. I could give you something a little more difficult, like y equals 3x plus 2, 6x plus y equals. It's going to be the same concept, though. Is there a single variable alone? Yes, there's a y. $1, same thing as this 4 quarters here. So in this equation, this dollar I'm going to change into 4 quarters. This turns into 6x plus parentheses, and you always want to put this in parentheses. 3x plus 2 equals 11. And that'll become more apparent when we start doing subtraction. 6x's plus 3x's is 9x plus 2 equals 11. Solve algebraically. 9x equals 9. X equals 1. Once again, like I said before, though, we are not done. You need to plug it back into here. Y equals 3 times 1 plus 2. Y equals 5. And you could always double check your work by plugging both of them in here. So if you want to double check, plug in both variables. So you could do 6 times 1 plus 5. Does that equal 11? 6 plus 5 equals 11. Check. And then you can try 5 equals 3, 1 plus 2, question mark. Does 5 equal 3 plus 2? Yes. So that is the first part. Not even the first part. That's like the first 3 parts of substitution. So turn the page here. When it gets more complicated is when there are negatives and subtraction. So you be careful. Also got to be careful. It's not always going to say y equals 2. So just be careful in that in this one, it's x equals 2. So you're replacing the x and not the y. Right. So on this one, you've got to remember how to distribute. 4y plus 2 plus 3y equals 9. 7y plus 2 equals 9. Minus 2 minus 2. 7y equals 7. Y equals 1. You can obviously tell that because I'm trying to do mental math, I've been choosing really easy numbers like 1. X equals 2 times 1 plus 1. X equals 3. So it could be x or y here. It doesn't always have to be y. So just be careful you plug it in the right spot. So when I'm talking about negatives, this is what I mean. Y equals 3x minus 1. Let's say 7x minus 2y equals 3, I think. So, you know, same concept. Box. Replace things. The question being, you know, we're going to replace this $1 with 4 quarters, right? And this is why I said it's going to be very, very important that you put these things in parentheses. Because when you distribute, when you're multiplying out, you've got to be very careful of these negatives. This is a negative 2 and this is a positive 3. So this becomes 7x minus 6x, because a negative 2 times a positive 3 is a negative. And then when you do this one, it's a negative 2 times a negative 1, which equals a positive 2. So you've got to be very careful of negatives, or else, well, you'll get the signs wrong, then you'll get the answers wrong. So watch your negatives, right? Negative 2 times negative 1 equals a positive 2. And then you just solve it like we've been doing. You know, 7x's minus 6x's is just 1x. You get x plus 2 equals 3. Minus 2 minus 2, x equals 1. Plug it back in. Y equals 3 times 1 minus 1. Y equals 2. So watch your negatives, or else you'll get the questions wrong, really. The last kind of question I might give you looks way different, but it's really not too bad. You'll get 5x minus 3 and y equals 3x plus 7. So it looks different from what we've been doing, but really it's the same thing. You just, when you plug it in and substitute, it looks different, right? That's my $1 turning into 4 quarters. This is my $1. So that ends up going there instead. And you end up getting 5x minus 3 equals 3x plus 7. If you remember, you want to get x's on one side, numbers on the other. It's easier to move 3x's than 5x's. The opposite of a positive 3x is a minus 3x. 5x's minus 3x's is 2x's. You get 2x equals 10. X equals 5. Plug it back in. Y equals 5 times 5 minus 3. Y equals 22. Now on this equation, just in case you're wondering, you could have actually, well, on all of them, you can plug it into either one. So if we would have plugged it into there, you've had y equals 3 times 5 plus 7, which is 15 plus 7, which is 22.